The demo will anyway.
Okay, yeah. So, hello everyone. Thanks for joining us today. My name is Murat Karstalı, VP Solutions at Maya Data. And Kiran Mova will give us a project update, and I will present the StackPointCloud demo part of the Hangout today. Go ahead, Kiran. Oops. Yeah.
Thanks, Murat. Hi, everyone. Welcome to this edition of the OpenEBS Hangout. I work for Maya Data, and I'm one of the maintainers of the OpenEBS project. I'll quickly go through what releases we have made and some of the activities we have been doing in terms of putting OpenEBS on the community landscape, and as well as some features that are under development right now. Right. If we go to the next slide, please. Okay. So since the release of 0.5 just before KubeCon, we've noticed a uptick in the number of people using OpenEBS. Some people have messaged us saying that they've actually put it into production, and also I'm seeing a rise in the number of discussions that happen on the Slack channel in terms of feedback, as well as trying to get it to work with different environments, etc. It's been pretty exciting. So we've also had a chat with some of these users to get their initial feedback, or really kind of get a sense of what they like about OpenEBS. The thing that stood out really is the simplicity with which you can use OpenEBS, or which also incidentally is the motto that we set out for OpenEBS. The storage operations should fade away, just like how Kubernetes provides you a unified cluster where it takes care of compute and network. By adding OpenEBS, your storage operations will also be as seamless as managing your CPU and network and RAM, etc. Right. So it's really been about listening to the users, getting their feedback, and also trying to see how they're deploying in different environments. This has led us to make a few point releases with the specific fixes that were required for these customers. 5.1 and 5.2 came in late last early Feb. We recently released a 0.5.3, which is again a point release with some of the fixes from the users. One of the things that also has changed since the last Hangout is the documentation itself. There's a lot of feedback on the improvements that could be made. So right now what we've done is we've kind of taken the documentation out of the OpenEBS repository, and it's right now under OpenEBS/OpenEBS docs, and it's online at docs.openebs.io. I like the new look and feel, but I think it's really the feedback that comes from the users that makes it better. So please take a look. We made it easy to provide feedback and also kind of edit the documentation itself. We love contributions. Right. Next slide, please. So in terms of the things that we have been working on, we've all heard from Jeffrey in the last Hangout about the CStore. That's something on the top of our agenda. And you will be able to play with the CStore engine pretty soon with the 0.6 release that's coming up, and 0.7 that follows that before the next KubeCon. Right. So OpenEBS really now can manage Jiva storage engine that was there all this while, and now there is a CStore engine. So to kind of let users choose what kind of engines they want to use for their storage workloads, we've refactored the way the volume policies were implemented in 0.5, which were basically parameters that get attached to the storage classes. But with 0.6, we have refactored it into a Kubernetes objects using these custom resources. So volume policies actually do two things. One is it lets users define their own properties that they want to assign to certain storage classes, and also they can extend what kind of attributes can get attached to the storage pods itself. For example, if somebody wants to assign certain RAM, certain CPU resource limits, users can actually create a volume policy that says, these are the settings that needs to get associated with this storage class related volumes, etc. Right? The policies itself are template based, so you can actually plug in any kind of labels or annotations that you want to add as well to the storage pods. So we've already seen integration or ability to monitor the OpenEBS storage via Grafana and Prometheus. The top things that are coming up is how to use Yager, Fluentd, and Open Tracing for the OpenEBS components. The PRs under review right now. So one of the things that we have observed while working on CStore and as well as this different storage engines is the way Kubernetes manages the underlying disks itself can be improved quite a bit, and especially when storage solutions have to be built on top of Kubernetes. I'll touch upon this in a couple of slides from now. So we are definitely making some extensions to Kubernetes to help manage the disks and the pools that you create on top of disks. We're trying to make it easier, which can be used by OpenEBS as well as any other projects that meet these kind of capabilities. OpenEBS uses iSCSI heavily for the data access part. So we have uncovered a few areas or areas of improvement that we could actually contribute back to Kubernetes. That's something on the roadmap. Snapshots and backing up to S3, etc. They've gone past the prototype phase. Now those are coming up as features in the coming releases. And then a couple of other things that keep coming back in our discussions with the users are ability to support read-only many for use cases where data needs to be shared by multiple pods. These are like jobs that run on, let's say, a data science project which retrieves the data from external location, and then multiple jobs just need read-only access to it. We are looking at how to implement that workflow. The capabilities are there. It's just about the workflow that we need to really understand and implement. The other thing is CSI. Yes, it's definitely coming. But I think in the priority order, we want to first have the CStore engine and the volume policies get in one release, and followed by that, we will start looking at the CSI integration. If there's anybody who wants to contribute to these efforts, please reach out to us. We also have contributor weekly meetings that are happening. You can sign up for that or just raise a GitHub issue to take this forward. Right. So while we are working on the features within the OpenEBS, it's kind of important for us because we are a storage service that runs on Kubernetes cluster to be integrated into the Kubernetes community and also the ecosystem that's built around Kubernetes, StackPointCloud being one of them, which is one of my personal favorite, which actually helped me make use or get familiarized with setting up Kubernetes clusters about a year and a half back, when it was not so simple to set up our own Kubernetes clusters. So OpenEBS is a trusted chart within StackPointCloud, which you can just enable it. Similarly, you can do this with OpenShift as well. Following some user feedback, we are now pushing the Helm chart of OpenEBS into Kubernetes charts itself under the incubation. While these are all the setup environment related one, there are some core features that we are working on to enhance the performance of the storage engines. One that's being actively worked on is the DPDK module. We presented some of our findings and also open source the parts that we are working on under the OpenEBS vhost user repository. The link for the presentation as well as the GitHub will be posted on the YouTube channel. Another update is we presented the OpenEBS to the CNCF work group itself. Got some good feedback on the features and some very good questions. we are contemplating on contributing some of the pieces or most of it into CNCF when it comes to that. Right? But even before getting into the CNCF, we have some projects lined up that we want to contribute into Kubernetes incubation. The one that I want to talk about now, and the one that's on top of my mind, is the Node Disk Manager. If you go to the next slide. The motivation for doing this really is we have RAM, CPU. These are some native constructs that are available at a node level, but there's nothing in the Kubernetes today that talks about a disk. A disk here could refer to a local SSD or a EBS disk or NVMe disk, etc. Right? The closest that we have is a local PV that just made it into the Kubernetes in the last couple of releases, but it has some constraints for use in solutions like OpenEBS or anything that depends on the identification of the faults in the disks itself before they happen, right? Some kind of a predictive failure kind of things are definitely missing. For example, if it is a CPU or RAM, there are some facilities already there that kind of can drain the pods from the node to the other nodes even before the catastrophe really hits it, right? But something similar is missing for the disks. So we're trying to enhance that by providing an add-on that sits within the Kubernetes as a daemon set on each of the node, managing the disks attached to a given node, right? The design for this is available in the link that I provided at the in this slide deck. There's also a OpenEBS Node Disk Manager project where we are building the initial framework where people can play with it. And the idea is we will push this into the Kubernetes incubator itself pretty soon. All right. That's what I had in terms of project updates. If there are any quick questions, I can take it, or we'll hand it off to Murat and Matt for running through the cool demo with StackPointCloud.
Thank you, Grant. Thank you for the updates. I'm working with OpenEBS partners and Kubernetes solutions ecosystem to enable new use cases on OpenEBS. And today we will talk about one of our great partner and also dear friend, StackPointCloud, and Matt Baldwin is also our guest today. So we are a big fan of StackPointCloud, Matt. And I'll start with what is a StackPointCloud. StackPointCloud is a universal control plane for Kubernetes. Supports all major public cloud providers from AWS, Google Container Engine, Google Compute Engine, DigitalOcean, and Microsoft Azure. StackPointCloud provides a control plane to deploy Kubernetes easily on supported platforms and helps you deploy solutions in your custom Helm charts as well as a federation of clusters. Currently, it supports Kubernetes 192 and 187. You can deploy your Kubernetes cluster using choosing Ubuntu or CoreOS images. And in addition to that, StackPointCloud provides easy deployment of solutions on top of your cluster like Prometheus, Helm, HA Proxy, Calico. Currently, there are 16 solutions and Helm installation from trusted charts that includes variety of charts from databases like Postgres, MongoDB, CockroachDB to CI/CD, Ingress, or message queue solutions like RabbitMQ and storage solutions OpenEBS. Matt, did I describe it correctly? Is there anything you want to add before we start the live demo?
No, sounded good.
Okay, so on our demo today, I will show how I deployed my cluster and OpenEBS to my existing cluster. While we wait for a cluster to get deployed, I will also deploy some example workloads and we'll add volume monitoring to my existing Grafana and add the dashboard. Let's deploy a new cluster. Let me move. So I have few already created clusters, and I will show how I deploy. You click on Add Cluster and choose a cloud provider, AWS, and you can set your master or worker size, disk capacity, and location, and you just enter your AWS credentials, and I already did before. It keeps the credentials, and click on Submit. You give it a meaningful name, or it creates a random name here. Let's demo 3. You can choose the Kubernetes version. By default, dashboard and RBAC are enabled. You can choose your Linux distro. I'll choose Ubuntu here, and then you can choose solutions to include into your deployment. So, and I will pick Prometheus, which also adds HA proxy by itself. And as soon as I click on Submit, it will start creating my environment. In the meantime, so this takes around 10-12 minutes to deploy 3 nodes. So in the meantime, I'll demo OpenEBS on a clean cluster. All I need is the public IP to connect, 53. That's the one. Yes, yeah. I will connect. Let's show number of nodes I have here, and so it's a clean cluster, no pods defined or no OpenEBS storage classes here yet, and I will switch back to StackPointCloud interface. To add OpenEBS from Trusted Charts, you click on Add Solutions and go to Trusted Charts. There are 23 charts here, and pick OpenEBS. And you can modify the YAML file here and give a namespace. I will say, let's use default, and click on Install. So this takes around 30 seconds. In the meantime, I will go back to my terminal and also clone OpenEBS repo here, since I have some demo files here that I'm gonna be using. And go to demo folder. We have some examples here from Cassandra, Postgres, and then Jenkins. I'll deploy Jenkins workload and maybe a database, Postgres as well. Let's start with Jenkins. In the meantime, let's confirm OpenEBS is up. You can see the state here. Jenkins, yeah. So I have a YAML file here. I will just apply that. So this creates the Jenkins deployment and service. We can check the pod status. Let's do that. Get pods. Container is getting created. In the meantime, we can get the status of underlying persistent volumes used by Jenkins deployment, and let's get PVCs. And then get the status of Jenkins service. Let's see services. Let's confirm pods again. Container is getting created. So from this, I will copy the service name. I wanna get the node IP address that is running the Jenkins pod to do the kubectl. describe pod and grab node. So this gives me the IP, and then I'm gonna need the port number as well. Jenkins service grab node port. Oops, yeah, I made a typo here. And the port is 30133. Okay, let's open a browser. All I need is the IP address from here. 172.231.119, port 30133. Okay, Jenkins seems to be functional up. Let's also add Postgres workload here. I'll close. Let me close the browser. This example uses the OpenEBS standard storage class. In the meantime, let's take a look at back to StackPointCloud UI to see what we can view there. After that, I will connect to my Kubernetes dashboard. So from control plane, you can see your deployments, and you can see included solutions here, and also download your kubeconfig and access to Kubernetes dashboard. Maybe I should zoom in. There are now there are a few things that we as OpenEBS team have contributed to Kubernetes dashboard, both ways, linking between storage classes. If you go to storage classes, when I deployed using the Helm chart, that also creates the predefined storage classes, and I was using the OpenEBS standard. When you click on that, it shows the list of persistent volumes that uses that cluster, that uses that storage class. You can see the capacity, and you can see one is used by Jenkins 5 gig, and other two are used by Postgres. If you click on one, the same thing here, you can see from your persistent volumes storage class associated with it, and you can click to get back there. I have Prometheus installed as part of my cluster. That was done when I created my cluster. So now I will try to add monitoring to my volume monitoring, storage monitoring to my Grafana dashboard. So I can go, there is a link, and I'll click on Prometheus endpoint. The default deployment comes with nice dashboards. You can monitor your nodes, deployments, and pods. So what I would like to do, so there are many ways to do this. So I'm gonna add our existing OpenEBS Prometheus deployment as a data source here. So what I need is let's call this OpenEBS, IP address of that, so I can go to my, I think fastest way, OpenEBS Prometheus, yes, here we go. And this is on 119 node, and I need the external IP for that. Worker nodes, I have 2 worker nodes, the public IP for that node. And the port is 32514. Here we go, data sources added. And I'll get back to dashboards, and I'm gonna import OpenEBS dashboard. All you need is the JSON file in OpenEBS repo. So under OpenEBS master, Kate's OpenEBS PG dashboard JSON, all I need to do is copy and paste the JSON file, load, and my Prometheus source is the OpenEBS. I could also change the existing configuration and do the modifications, but that feels faster. Okay, so now we have OpenEBS volume stats dashboard, and from this dashboard you can choose persistent volumes to monitor. So we had 3. This graph, because we just created, doesn't have history yet, but over time gets populated with IOPS, throughput, latency, capacity used, uptime of your volume, and then storage usage. This part concludes my demo, and now we can move to Q&A and take question if you guys have. I'm gonna move back to StackPoint user interface. Any question from audience? Okay, if not, so I have a question for Matt. What's the line between solutions and trusted charts? So solution seems to be more
Yeah, so
detailed with, yeah, you can.
yeah, so solution is where we've done a lot more work to get it to actually work inside of Kubernetes. So it's where there might not be a clean Helm chart to do the solution. So take something like Turbonomic as an example. To install Turbonomic as a solution, we actually have to stand up an AMI at Amazon and do some other work before we can actually stand everything up inside of Kubernetes. So that's kind of why we separate solutions and trusted charts. We're actually going to kind of combine it all into one giant marketplace. But that is kind of the line right now. Is these are ones that we've had to do extra work.
Yeah, there are a lot of good ones here. And we can also add custom charts, yeah, because trusted charts is a process, yeah.
Correct.
Privately, right?
Yeah, you could also add your own, if you have your own chart repos, you can add those through the interface, and then those become, you basically can choose from that list. If you have a private repo that has a chart or charts in it, you can also add that, and then that can, your users can use private charts. Because most of what we're engaging with are people starting to move their own custom applications into charts as just internal apps.
Matt, would you like to talk about some of the ways in which the solutions are being used? For example, I see EFK or STO that's listed there.
Yeah, so with EFK, so the reason we ship that is that when you drop that into the environment, that sets up basically all of your logging for your services, where we're just setting up Fluentd, Elasticsearch, and so Fluentd is feeding everything into Elasticsearch, and then Kibana, we've set that up to kind of surface that information up to the user. Things like Istio, what we do there is we do all the pre-install steps for Istio. The direction with Istio that we're going to go is to increase the level of management that you can do with Istio through the interface. So things like rules, traffic management. With Istio, what we're seeing with users doing right now, there's very few production users of Istio right now, but we do have a production user that that we know about that will be presenting at a cloud native event that we're doing. I can't speak for that customer right now, but they're using it to collect telemetry information. So they are not just looking at telemetry information for the services running inside of Kubernetes. They're also pulling in third-party telemetry information from physical hardware as well. So that's how they're using Istio. So they're doing kind of outside of VM type of work as well. So that's one interesting use case. Turbonomic, we're seeing customers use that to do more advanced scaling stuff. So they have basically like an economic model inside their software that will dynamically scale based upon certain triggers. So suddenly you've set a SLA on your service, and that SLA maybe a certain response time. What that Turbonomic combined with what we do allows you to do more advanced scaling, basically outside of what the in-project autoscaler allows you to do. So if you look at the autoscaler in there, that's the project autoscaler, and that's a lot of contributions from our side to introduce a few things like we do node pools and stuff like that with autoscaling. We're also seeing a lot of users with Cloudflare right now, because that's basically a secure tunnel that users are so you can set up multiple Kubernetes clusters, and you can have a secure tunnel that connects up to the to Cloudflare's ingress endpoint, and then you can actually, if you have a user on the East Coast hitting that endpoint, it can actually route that traffic to your East Coast cluster. Yeah, but if you have a user coming on the West Coast, they'll obviously get routed to the West Coast cluster. So that's an ingress control that we ship as an option. And that's all open source too. We wrote all the code for that controller too. So that's kind of like also the extra work that we've done for this list of stuff. Some of this is also, like the Cloudflare ingress controller is all of our own custom code, as is the HA proxy component. Nestil is an interesting question because they were just acquired, but they're a monitoring solution, somewhat similar to Sysdig. So we're seeing people actually use combinations. We're not seeing people just do one thing. We're seeing people do usually EFK, Prometheus, and starting to play around with Istio. We're not seeing too many people drop in Linkerd anymore. We're seeing a lot of Fabricate usage as well. Fabricate is a development platform, mostly used by Java developers.
Cool. So when we use EFK or Prometheus, how long do you keep the data, or how does a user configure that?
I don't have the answer for that off the top of my head. I'm happy to check on that though and get back to you. Like I don't know how long I don't know what our default retention time is set to.
Right. I was just chatting with one of the users who had this interesting question about EFK. He was asking, are there any policies that we can set on EFK where the older logs or the older data can be transferred to a cold storage and not archived, that kind of features?
I think you could do, so I think if you were to use the Elasticsearch operator, I believe you'd be able to introduce that. If that functionality is not there already, you'd be able to introduce the functionality inside of that operator. I don't know if it has it in there or not, but that's where that would happen.
Cool.
And there's multiple operators for Elasticsearch. So get the one. So the best one would be the one from Elastic themselves.
Cool. Thanks, Matt.
Any other question? I have another one. So under trusted charts, you have many stateful workloads and databases and others. What are the challenges that you see or hear from your customers about providing storage to persistent workloads?
We're seeing a lot of, outside of, so we, since we support all the cloud providers, we're supporting the dynamic volume stuff. And so a lot of users are using that. So PVCs, they just declare PVC and get an EBS volume. But we're also seeing, so some platforms where we've introduced block storage, things like DigitalOcean, there's still some issues with their underlying block storage. We're still seeing customers there build out things like Ceph environments to host their content and their data. We still see a lot of FUD around the databases. We still get questions: is it safe to run a database inside of Kubernetes? And there's still a lot of conflicting data out there. We're seeing more and more people do it. Less, initially we were just getting all stateless customers, but now we're getting mostly it's Postgres is going to be the one that's most popular right now that we're seeing. We're not seeing a lot of Kafka. But out of that list, I was just reading down the list. But we're not seeing a lot of MySQL for some reason. We're seeing more Postgres. We have a Mongo solution where we introduce replica sets and things like that. Yeah, that's pretty much where it's at. Customers are kind of all over the place at times. We're also seeing issues with certain providers where we can see things like where we've seen mounts go into kind of like a state where the mount's kind of orphaned, and it's not removed from the host. So we've seen that type of issue. So I think a solution like OpenEBS would be ideal for a lot of these use cases to avoid things like that.
Providing an abstraction, yes.
Yeah.
And probably one last thing we haven't talked about, federation. You wanna?
Oh yeah, it's
a large topic, I know.
Yeah, that's a moving target topic. I mean, I don't know if everybody's aware that federation in project is being heavily discussed, and they're moving towards something called multi-cluster. And so what we do is we support the current implementation of federation inside of Kubernetes, so the federation control plane. We allow you to stand up clusters of multiple providers, and then we allow you to connect, kind of bring, kind of build a federation out of those clusters, 2, 3, however many clusters you need. We allow you to add a cluster, bring in a new cluster. If you already have a federation, you want to bring a new one in, you can do that. You can disband the federation. We also have added functionality that, if you have a federation and you have existing workloads, so say you have an Amazon cluster, right? And you have existing workload on that cluster, and now you want to build out a cluster at Google, right? You can actually now do that, and then you can also choose at the time of building out the federation, what percentage of your workload you want to have running at Google versus at Amazon. So, say you want 50-50, you can do that. Obviously there's other requirements that, that's where kind of the Cloudflare thing comes in. So you have like a central ingress endpoint, basically a GeoIP that you can hit. That's going to route you to the right cluster for the right service. But we do allow you to now start to split load across providers. So that's kind of the federation story there from us. And eventually we're gonna span it into hybrid as well. That's what we're working on.
Any final question?
Just a quick one. We are trying to move to this Kubernetes incubation, right? How does this impact the integration with the StackPoint, Matt?
I'm not sure I'm following the question. What's the what integration point would be?
The Helm charts are OpenEBS Helm chart is getting integrated to Kubernetes charts direct, the repository on Kubernetes. Does StackPoint have a way of getting whatever is already there in the Kubernetes charts and incubation directly?
No, we don't. The reason we don't pull directly from Kubernetes charts is the charts community vets the charts for kind of like looks at the charts for best practices, and it doesn't look like a well-written chart. What they don't do is they don't actually ever test the charts. So we've had issues with charts actually not working. If you actually go to use the solution, there's problems with the chart. So until they can fix that issue, we're not pulling from the community. So with all of the stuff that we do is we'll go like, our requirements are, to submit it to trust charts as, the vendors, someone's created, tested it against the clusters that we do. If we edit it ourselves, we've actually gone through and verified that solution actually does stand up at all of the, providers that we support, and that that you can manage it. So we do a little extra work on top of like what the community does. But yeah, that's the primary concern, is that sometimes those charts don't actually stand up the solution correctly. There's one thing for a Helm chart to do a successful install of the deployment to come online. It's another thing to say that deployment came online correctly, and that there's a way to verify that it's successfully running. So Kafka, how do you verify Kafka is actually running in the way you expect it to run?
True. Sounds good. Yeah.
Thank you so much, everyone. If you don't have any more questions, this is the end of today's Hangout. Thank you for joining, and the recording will be posted on our YouTube channel. Thank you.